is Amber Rohr.
I'm Danielle Caserta.
My name is Jared Jackson.
And I'm Lauren George. And today we're talking about the bouncing tennis balls activity. And in this activity, students are working towards collecting data and later on they will be graphing it. And the good thing about this activity is that it connects it to the real world. So students will be bouncing a tennis ball, recording their data, and graphing it. And they're working towards recognizing the different varies in the experiment and finding independent and dependent variables.
Okay, so this lesson basically focuses on one question that the students are presented with. So they are asked to figure out how many times each of their team members can bounce a tennis ball and catch it in 2 minutes. So the students will be performing small experiments in 2-minute intervals, and each student will be able to do the bouncing and the catching, but students will be in groups of 4, so each student will have a role, and they will rotate these roles so that each of them gets a turn. So each of the roles, there's a timekeeper, there is someone who is actually bouncing and catching the balls, there is a person who is counting the number of bounces that the other student is completing, and lastly, one person is recording their data in a table that looks like this, with the time, the number of bounces. And so this process, each student will be doing a 2-minute experiment and they're recording their data. Then they are graphing their data. So they are going to take their data from the table and graph it so that you can see the cumulative bounces over 2 minutes. Then they will try to find their line of best fit and present their results to their classmates. And then the teacher will engage their students in a discussion about the lesson, about what they've learned, see if they're making connections and understanding the relationships behind the activity. So they could be giving some guided questions such as what varies in the experiment so that the students are understanding the difference between the independent variables and the dependent variables. They could ask them, what would your graph look like if your scale changed? And trying to make sense of whether the students understand how important it is to create an appropriate scale for their graph and how it would change if they change the scale. You could also ask them, what is the steepest of the line related to? So this is getting students to understand the concept of slope and then also their line of best fit. Did they connect their plotted points together, or did they leave them as a scatter plot and then just create their line of best fit through it? Also, they need to understand the difference between distance and speed and kind of getting to understand the relationship between the number of bounces and their time intervals.
Okay, so once the students have completed their experiment, they will have created a graph or chart that looks similar to this one. Not exactly, because they will have had a different number of bounces for each trial. In the left column, we have an already pre-recorded set time in seconds, in 10-second intervals. In the second column, their number of bounces per 10 seconds. And then in the third column, their cumulative number of bounces. So for example, after 20 seconds, they had a total of 22 bounces. In your packets, after the actual lesson, we have a graph that the students will be filling out to complete the activity. So this is what it will look like for the students as they're working on it. And then once they're done and that is all filled in, they will be entering their data into a scatter plot so that they can create a line of best fit. The students will be graphing based on the number of bounces they have and then versus the amount of seconds it took to get to those bounces. So this will be a graph of the cumulative number of bounces. And then once that is done, the teacher will be walking around listening to the conversations the students are having, listening to make sure they're grasping the fact that after 20 seconds they should have 22 bounces. After 30 seconds they should have about 33, 35 bounces. So there is a linear progression in the number of bounces they are getting. After that is completed and the teacher is certain that the students have received that, they will be asked to create their own line of best fit. So this will be done using a pencil and a ruler. The students will graph showing what they think is the closest line for a linear progression to the data they have collected. After that is finished, the teacher will present how to use the actual line of best fit. So the students will be asked to find the slope between 2 points of their data, and then using the slope, they will enter that into the equation that the teacher discusses for the line of best fit, and the students will be asked to find their own line of best fit for their data. And then after that's finished, the students should be comparing with each other to see whether what they received is similar to the other groups, which it should be. Can you flip over? Okay, so this is an example that we have created using our data of what we would have plotted in our for a line of best fit using the data we found for our experiment. And then,
Okay, so looking at the connections to algebra, since it's a lot of probability in data as well, we're going to try and turn it to connect it with just specifically algebra. We're collecting and analyzing the students are collecting and analyzing the data, and then they're graphing it. And they're identifying independent and dependent variables throughout their experiment, as well as applying algebraic equations. And building a sense of time and its relation to distance and speed is very important as they're building their different equations for algebra.
Okay, some way that you can extend this experiment to beyond what is already there is by adding different variables. For example, you can have the students bounce the balls on concrete floors, carpeted floors, or tiled floors, which should alter the results, and they'll be able to compare the results that they have and see the different lines of best fit and the different graphs that they're going to make. Students can also try different similar activities if you don't have tennis balls available or if you just want to expand the lesson. They can try clapping their hands for one clap every second for 10 seconds and graph that and see if they can have how accurate they are with their line of best fit. Another similar activity could be turning a page in a book every 2 seconds for 20 seconds. So there's a lot of different things that you can do to change the variables and have them have different graphs. For assessment, as students are doing the activity, you want to make sure that they're making their graphs correctly to scale, making sure that their points are being plotted in the right places, and making sure that they're seeing the relationship between the points plotted or between the number of bounces or whatever variable you have and the time. Okay. Also, yeah, no, that's good. Go ahead. So, in conclusion, this lesson is really good for students learning how to collect data and naming independent and dependent variables, and really just looking at the relationship between the variables and relating it to the real world. So,
thank you.